Standardization.
All right, thank you.
Thank you. Thank you, everyone, for joining us today. My name is Joe Linscott. I'm a product manager at Microsoft. Raghu?
Hi, good afternoon. My name is Raghu Yeluri, and I'm a chief architect at Intel. If you heard of Intel Trust Authority, I'm the architect behind that.
Cool. Thank you, Raghu. Today, we're going to be talking about Microsoft interoperability efforts towards attestation standardization. If this works. We'll just do it that way. So the first thing that we'll talk about today is understanding confidential computing as a whole. I know we're at the Confidential Computing Summit, but we need to have one slide where we talk about confidential computing as a whole and how attestation plays an important part in confidential computing. The second thing that we'll discuss is the interoperability requirement and the challenges that we see with attestation today. And then the third piece that we'll discuss are Microsoft and Intel's standardization efforts with a call to action to you all in the room to help us. So the first part with all these decks that I've seen today is what is confidential computing? The first thing I like to do, or the way I like to explain confidential computing to someone who's not aware, is first start with what you know. So we have data at rest and data in transit that we protect today, kind of by default. It's kind of like an industry standard by this time. So with data at rest, if you were to steal my laptop today after the conference, it's encrypted with BitLocker, so you're not going to be able to see the data on my laptop. Same thing goes for data in transit, right? If you go to your bank's website, there's a little lock icon on the top left of your browser showing that it's encrypted. And it took a long time for us to get to those places for both data at rest and data in transit. And the same thing is kind of playing out right now with data in use. Or as the definition goes, protecting data in use by performing computation in a hardware-based, attested, trusted execution environment. So it's kind of crazy, at least to me, with confidential computing, where we now have a space where we're protecting data from the time it's created to the time it's destroyed, all the while protecting against would-be privileged access admins or exploiting bugs in hypervisor or whatever have you. There's plenty of attack vectors, so it's really important. So now that we know what confidential computing is and how we're protecting data in use, we can't just trust it, right? That's not why we're here. We can't just implicitly trust things. We have to make sure that we can trust it. And one important part of that is attestation, establishing trust with your execution environment, or the acronym up there is Trusted Execution Environment, TEE. With the official definition of attestation ensuring the trustworthiness of your execution environment prior to code execution or sensitive data disclosure. So you want to make sure you trust that environment before you send it your secrets, before you let it execute your code. So that's a lot of words, but what does that actually look like in practice? So on the left-hand side here, we have the sample attesters. We've got an Intel SGX, an Intel TDX, AMD SMP. Hopefully you know these names and their acronyms by now, but these are execution environments, right? And we want to be able to trust them as a confidential computing environment. On the right-hand side, we have relying parties, and the relying parties want to use those sample attesters there. They want to use them confidentially, but they can't trust them immediately, right? They have to perform attestation. So the sample attesters in this scenario will send over their evidence to the sample verifiers. That evidence might include a certificate generated by the manufacturer, as well as maybe a hash of the build environment and maybe a few other things. The sample verifiers in this case are a Microsoft Azure Attestation or an Intel Trust Authority. And they'll take that evidence and they'll go, okay, do I trust who issued the certificate in this evidence? Do I trust the hash of the build environment? And it might go through a series of checks, right? Is it meeting my security baseline? Maybe a few others, depending on policy. And after that's complete, it may produce a attestation result. And once that attestation result is generated, it'll eventually make its way over to the relying party, the person that wants to use the sample attester, right, on the left-hand side. It wants to trust it. So it gets this attestation result from the verifier and says, okay, can I trust who generated this attestation result? Is this attestation result valid? Has it not been tampered with? And it will also look at the claims. It'll look at that original evidence provided earlier from the sample attesters and say, does that meet my security requirements? Does that meet my security baseline? And once that's complete, it makes the decision, yay or nay, can I trust this attester environment? That's pretty much it, but it kind of gets a lot more complicated, right? I have a lot of pictures up on this screen. I just showed just 4 different attesters. I showed just 2 verifiers. But the problem grows a lot more when you add more attesters, you add more verifiers, and then each attestation result has different formats, and each evidence piece might have different formats as well. And so all these people have to consume and construct for different things. And that's where Raghu's going to come in and talk a little bit more about that on the next slide.
Okay, thanks, Joe. I'm going to go back to the picture for 1 second, maybe. Yeah. All right, a couple more words on this picture before I go to the next one, right? We hope that the number of verifiers are going to be few, okay? There's Microsoft Azure Attestation, there's Intel Trust Authority, I'm sure there will be few more, and if you are really the brave ones who want to do it yourself, there will be do-it-yourself verifiers. But in this ecosystem, the expectation is there are few verifiers, there will be few attesters, okay? Joe talked about Intel TDX, SGX, AMD, NVIDIA has their own confidential environment, ARM has their CCA, so there will be a small set of attesters. We expect a small set of verifiers. Where it's going to really fan out is the number of relying parties, okay? In a confidential computing environment, a relying party doesn't do anything with the workloads or what's running on these attester environments until they get a verification from the verifying system, okay? Relying parties will be thousands, millions of them, okay? Any application that's using confidential computing is going to be a relying party, okay? So now if I overlay all the data formats that need to happen in this picture, this is what it looks like, okay? There are Intel SGX and TDX, they have their own evidence formats. AMD, SCV, SMP, they have their own evidence formats. ARM has their own evidence formats. NVIDIA has their own evidence formats. So if I'm a verifier writer, I have to know how to deal with all these formats, okay? I can't just say, I'm going to write to one format because there isn't a standard there. And if I'm building a verifier, I can't say I'm just going to build for Intel SGX or just for Intel TDX. We are in a very heterogeneous world. You're going to have a whole bunch of different attester types all working together in a cloud environment. So your verifier needs to deal with all of those, okay? Then the second thing is the reference values, okay? One of the fundamental things a verifier does is it's going to take the evidence. There are some measurements in there. It's going to get the reference measurements from a secure source, which is typically the root of trust for that attester, and it's going to do some comparisons, okay? The good news, at least, is on the reference values, there is some standardization that's beginning to come, okay? CORIM and COMID are 2 formats that people are beginning to converge towards, okay? But still, as of today, it's very likely that the providers have their own representation of the reference values also, okay? So a verifier has to deal with that as well, okay? And then the last one is the appraisal policies. You need to have some ability to control what the verifier does and what it returns as a result. That's controlled through an appraisal policy. There are no standards there either, okay? In Intel Trust Authority, we use RAGO, the OPA RAGO as our policy representation and policy execution mechanism. Microsoft has their own mechanism. Others, I'm sure, will have their own ways of doing it. Eventually, they may all converge on something like OPA RAGO, but it's still work in progress, okay? Now you can see the verifiers have to deal with a lot of different input sources, input types, so that they can process the information in a uniform way, okay? Now, all of that is done by the verifiers, and they provide you an attestation result, okay? Even for TDX, Microsoft has their own TDX schema for their attestation report. Intel Trust Authority had their own mechanism for representing Intel, the attestation report. AMD SCV would have their own. If MAA is doing for AMD, it would have its own. If when we are doing for AMD, it would be a different format. So now imagine you are a relying party, right? You have all these various attestation result formats that are coming to you. How do you process those? How do you write a relying party to deal with all of those? Okay. Now to add to this problem, there are some higher level mechanisms like AR4SI, which is another attestation result format which doesn't deal with technical claims. You know, like the TDX ones, the AMD SE ones, they deal with very technical claims. It says this measurement we verified against this value and it is good. So very technical representation of assertions. AR4SI, for example, is very high level. It's used in the IoT industry and those kind of things where it says, is this good or bad? Just very binary kind of high level verification mechanisms. Okay? So now a relying party has to deal with all of these things. So this is where the whole interoperability discussion comes. Relying parties are having to accommodate too many formats. They have to write very unique code for each verifier type and for each policy representation formats. Okay? Imagine you are the relying party writer. Okay? You have to deal with all of these yourself. Okay? And then the next downstream problem is, okay, you spent the time, you invested the time, you did all that in your relying party code, right? Some things are going to change, something gets updated. You have to maintain all your relying party code. So it's a huge expense and for you as a relying party owner to manage all of these things. What is really required is let there be a standard representation format for relying parties so that whatever the verifier, you may use one verifier, you may use two verifiers, n number of verifiers, the output is always going to be the same so that you write that code in your relying party once and doesn't matter which verifier you're using. Again, the question you may ask me is, why would I use different verifiers? Depends upon your security properties. Okay? If you were there in the morning keynote when Mike Bursell from the Confidential Computing Consortium said, do you always trust the cloud provider who is giving you the trusted execution environment also to provide the attestation? In some cases, it may be fine, but maybe there are some applications where that is not acceptable. You need a third-party attestation system. So now you have a situation where you wrote a relying party that was working with one attestation system. Now, based on security requirements, you move to another attestation system. Your relying party is broken now. Okay? And the other thing is you need one authorization mechanism for verifiers. Okay? I can't say when I'm working with this verifier, I have my own authorization mechanism. When I work with Intel Trust Authority, I have a different authorization mechanism. Okay? So these are real problems in order to scale confidential computing broadly. Okay? So far, the talk has always been, hey, we're going to give you a nice isolated environment. You can run your applications there. Everything is going to be good. Yes, at the highest level, that is true. Okay? But when you get down to the nuts and bolts of it, these are the problems you're going to run with. Because you're going to build relying parties. That is the fundamental thing you do in confidential computing. Your application is a relying party. It's relying on somebody to say that that hardware on which I'm running my code in a trusted execution environment is trustworthy. It is what I expected it to be. And the code that's running inside there is what I wanted it to be also. So you have to be a relying party in some form or fashion, which means you're going to run into these problems. Okay? So this is where Intel and Microsoft, said, how do we approach this interoperability? So we said, at the highest level, we want to get standardization done across all those data formats that I showed you in the previous slide. Okay? If all of that happens, you write your relying party once, and it works no matter where you are. Okay? But that's the grand vision of where we want to get. And the steps we decided to do was, what are the two things that are going to have the highest impact for the interoperability discussion. We narrowed it down to attestation reports because that comes into a relying party, and appraisal policy, which is what a relying party sets in the verifier to say what kind of verification output that you want to generate. Okay, so attestation reports and the appraisal policies are the two things that we started to focus on. So what did we do so far, right? We said, hey, if we have to standardize, we have to look at something that is already where the audience are very well familiar with, which is IETF remote attestation mechanism. So we said, okay, we will create an EAT profile. EAT stands for Entity Attestation Token Format, which is typically how people specify what formats for attestations are. Okay? We said we're going to create a draft version for TDX, Intel TDX, and said this is what MAA and Intel Trust Authority are going to use, so that when these two verifiers generate an attestation report, it's going to have the same exact format, same exact claims. Okay? And we said we're going to put this into the standards process. We're going to encourage all verifier guys to use it. We will encourage community participation so that we can make sure that we are not missing anything in the technical claims definition of that process. Okay? The second thing Intel and Microsoft collectively agreed to do is, hey, we will work with AMD and do something very similar for SCV SMP, just like we did for Intel TDX. So that when MAA generates an attestation token, when Intel Trust Authority generates an attestation token, when Verizon generates an attestation token, it's going to have the same format. Okay? And the one after that would be, hey, if you have confidential GPUs like NVIDIA's, we will do something similar working with NVIDIA on that, so that doesn't matter which verifier generates the attestation report, we're going to have the same formats. Okay? So let me show you what, so before I even get in there, right? So we created this shared profile. It's called Intel TDX EAT shared profile. We put it into the IETF as an IETF draft proposal. It's going through the community process. Eventually, we'll take it through the standards process, and hopefully it's going to go through there. But we didn't wait for that thing to become a standard yet. So we took that shared profile, and Microsoft modified Microsoft Azure Attestation for TDX to use that shared profile. Intel Trust Authority modified its attestation report to use that shared profile as well. Okay? So this is what an attestation token, if you use either of these two verifiers today, this is how it's going to look. As you can see, most of the technical claims are identical. They are named the same between these two systems. Okay? You notice something which says XMS on the bottom. Okay? There are 3 or 4 like that. Those are unique to Microsoft. Okay? They kept it for backward compatibility because they don't want to break their old attestation reports, so they kept it for backward compatibility. Intel Trust Authority has a few like that too, which are very specific to the way we do some things. But 90% or 95% of the claims are identical between these two systems. Okay? So the benefit for the relying party is this. They could be using MAA today for whatever security requirements they have for their relying party applications. They could be using Intel Trust Authority tomorrow. They don't make a single line of code change because the claims that they are trying to verify against, they are named the same between these two systems. So you write your relying party once, and it works irrespective of which verifier you're using. Okay? Now you can extrapolate this thing to confidential GPUs. Okay? H100s, the B100, B2000, 200s, you go from MAA to Intel Trust Authority or to another attestation system, the claim names would be the same. So your relying party code is not going to change. Okay? So with that, I'm going to bring Joe to wrap it up. We are maybe out of time in a minute here. So.
Thank you, Raghu. So hopefully the problem statement there really kind of came home to everybody, that in order to make this work for everyone, for the millions of relying parties that Raghu mentioned in the future, we have to standardize on attestation. So there's two things that we're asking from all of you today in the room. One, if you're a relying party, AKA anyone that wants to use confidential computing, review our Intel TDX e-profile proposal to ensure it fits your needs and your scenarios. We'd love to hear your feedback on it. The second thing, if you're a verifier like a Microsoft Azure Attestation or an Intel Trust Authority, collaborate with us to enrich the e-profiles and policies with essential claims to help establish it as a standard. Again, thank you so much for joining us today, and I think that's all we had for you all, so thanks. Questions?
One question, maybe.
Yeah.
Go ahead. Go ahead.
Okay. Yeah, this is for you. Why did you just focus on AR? Why did you actually modify it, make the TDX attestation e-compatible?
With AR4SI? Which one, I'm sorry?
The attestation itself, right? You said you're using an e-profile for attestation results, right? But then there's the attestation evidence, which is encapsulated, which is encapsulated in the TDX. Why was that not feasible to make that
Eventually that's where we're going to go, okay? So like I said at the beginning, right, the real fan out is with the relying parties, okay? The output of a verifier, which is the attestation report, that's the one that touches a lot of relying parties, okay? The evidence, which comes from the hardware, the attestation reports they call them, it's mostly for the verifiers. And there will be a small set of verifiers. And it's a much more manageable problem than dealing with all the relying parties. That's why we said the big bang for the buck is going to be to make sure that the output of the verifiers is standardized so that all the downstream relying parties have a very uniform way to deal with it.
Okay, but it wasn't a practical issue that was preventing you.
No, it's not.
No urgency for doing it.
It is not a practical issue at all. It is just where do we prioritize, and that's where we prioritize first. And the next thing we're going to do, like I said, is the policies. Okay.
Thank you.
Thank you.